welcome to another episode of I Am Nano.
Filling the I, and I am Nano. I am your host, Irfani.
And I am your other host, Monica.
And today's lit update, we will be talking about using nanomaterials for developing wearable microneedle sensors.
Yes, super cool microneedle sensors. Now, are they supposed to be a painless way to monitor biomarkers in your body?
Yes. So microneedles come in varying lengths and they pierce the superficial layers of the skin, the epidermis and the dermis. They are a much less painful way than the hypodermic needles that are usually used for blood extraction in the clinics.
Oh, I've heard of these minimally invasive, painless blood detection systems before.
Yeah, it's something that scientists have been working on for a very long time. And unlike Theranos, who claimed that their technology was working, researchers are continuously making promising progress.
Oh, that's good to know,
Yeah.
right, for sure. And now there are continuous glucose monitoring systems for diabetes management available in the market right now, which is good. And they monitor the glucose levels in interstitial fluid.
It is a small patch that you can stick on the back of your arm. It's a wonderful technology for diabetes management. But right now, the commercially available ones is only for glucose monitoring. And so researchers are focused on developing ones for other biomarkers.
Now, that's very important. There are many different types of fundamentally instrumental important biomarkers for sure. And the research was conducted by scientists from Israel and China, and it was published at the beginning of 2022 in the Journal of Advanced Materials. Now, these scientists developed a microneedle sensor platform that can monitor sodium levels in real time.
So the solid microneedle was made of polystyrene that was then coated with titanium and gold to make the working electrode. And then another set was coated with silver for the reference electrode. The sensor operates through the extended gate field effect transistor mechanism. In field effect transistor-based sensors, the current that is flowing through the semiconducting material changes as the biomarker concentration changes.
And in this case, a sodium selective membrane composed of sodium ionophore X, some sodium surfactants, and also some polymers was placed over the sensor.
What are ionophores again?
Ionophores are molecules that allow certain types of ions to pass through. They reversibly bind to ions and are often integrated into a membrane. So they're like the little checkpoints at a gate in, say, a tightly secured company or organization. Only those who belong to the company or organization can pass through. In this case, it's the sodium ionophore X.
Oh, sounds fancy. Ionophore X. By placing this ionophore containing membrane, the sodium ions bind and then diffuse through the membrane. And this increase in cation charges on the electrode changes the electrical charge on the sensor and alters the FET sensor's current.
And so when the microneedle sensor was exposed to solutions with different sodium concentrations, the detected drain current increased with increasing sodium concentration. The sensor remained stable after multiple applications and peelings from the skin, showing that it is a highly stable compound for continuous use. And it can detect fluctuating sodium levels very accurately.
This is really important. Biomarker levels fluctuate depending on what you eat, the treatments that you use, and just your general activities.
And you want the sensor to be reliable if it's going to help your doctor assess the appropriate treatment for you.
And remarkably, the long-term study indicates the sensor is stable for up to 8 months.
Wow, 8 months. Now, is that considered a very long
That's
time?
very long. That's a very, very long time.
Very long time.
Yeah. Now, the human body is a very complicated system, and there are other factors that you must consider when you're making wearable sensors. And one of them is what happens when your interstitial fluid's pH changes. And it can happen if you have like certain diseases.
Now, does the sensor's response change with different pH levels at all?
No, it actually doesn't. And there was no significant changes observed with changing pH levels, which is, great.
Yeah, that is really great. And now, how about other potential biomarkers that might interfere with the sensor response?
Well, in the presence of other ions such as potassium, calcium, the sensor response didn't change significantly. And they also did another test by functionalizing the sensor with other bioreceptors, such as polyaniline, that is responsive towards pH levels, and then glucose oxidase that detects glucose levels, and anti-cortisol antibodies. And the sensor only showed response when it is exposed to their target and not the sodium.
Oh, wow. And that also demonstrates that the platform can be used to detect other biomarkers.
Yeah, so this platform is very, very versatile. But in this paper, they're mainly testing it for sodium detection. Now, before testing it on humans, we have to, make sure that it's safe.
Of course, yeah.
So they tested the safety through both cell and mice studies. They incubated the microneedles with osteoblasts and fibroblasts for 24 hours and found no significant change in its viability compared to the control. And in the mice study, the mice organs and immune inflammatory responses didn't show any adverse effects to the body, even after 7 days of wearing the microneedles.
Oh, that's awesome. You can wear it for a week and really good to know. And now that the researchers have determined that the microneedles are safe, they tested it on a healthy person. And to confirm that the sensor was accurate, they also tested the person's sodium sweat levels after exercising using a commercial sodium meter. So nice way to compare. And it was observed that the fluctuations in sweat levels were comparable, but there was a 40-minute time lag in between the two. And that was mainly because sweat is produced from the interstitial fluid and must be generated onto the skin surface.
This is really great and promising for the future of microneedle-based sensors, but we still need to test it under different conditions to make sure that it can still perform well under various activities.
Yes, for sure. Agreed. Oh, and we should note that the sensor also used silver nanowires to connect the microneedles to the remaining electrical system. Now, the platform then is also integrated with Bluetooth technology so that the data can be sent to the doctor, and then the doctor can contact you directly when they notice any concerning signals.
This is the future of personalized medicine, people. Sure. Hopefully, these types of devices can help us, lead healthier lives. All right. That is all I know for today. Take care.
And stay curious.